what is the value of square root of, and under the square root we have 2020 square plus 2017 square minus 2019 square minus 2018 square. And we're given 5 options in order to choose the correct answer. So whenever we see a big expression like this involving squares of large quantities, one thing to know for sure is we don't want to go the laborious way of calculating each of the squares and taking the sum and so on. And while that may eventually lead you to the right answer, in time tests like GRE or SAT, you may end up losing a lot of time. And usually these problems are simpler to do, like I'll hopefully demonstrate here. So one of the things that we note here, that in that expression within the square root, or within the parenthesis rather, we have sums of squares, but we also have differences of squares. So the first thing that we do is basically regroup certain terms within that expression so that we have differences of squares. And we do that primarily for the reason that for differences of squares of two quantities a and b, we have this basic algebra formula: a square minus b square is equal to a plus b multiplied by a minus b. And that's a convenient way, it's often a convenient way of computing differences of squares or calculating differences of squares, because you may potentially reduce especially the difference a minus b to a smaller number. And in this case, these quantities like 2020, 2019 and 2018, 2017, they have a difference of 1. So that really helps dramatically reduce the amount of calculation involved, because if you just do the expansion into that form, you'll immediately see. So the first term, 2020 square minus 2019 square, becomes 2020 plus 2019 multiplied by 2020 minus 2019, which is 1. And the second one becomes 2018 plus 2017 multiplied by 2018 minus 2017, and 2018 minus 2017 is 1. So you are left with a simple algebraic sum of numbers. Now I may still not want to add up these numbers, so I regroup them once more, this time taking 2020 minus 2018 plus 2019 minus 2017. So breaking them up like that really helps me avoid any kind of large calculation, even if it be addition or subtraction. So it's simple to see that the first term is 2 and the second term is also 2, so 2 plus 2 is 4. Now we are asked to evaluate the square root of this, so square root of 4 will be 2. So the correct choice will be the option C in this case. Moving on to the next problem, and this is a sort of a word problem which needs to be read and interpreted correctly, and often converted into simple equations for easy solving. So the problem goes like this: a farmer has chickens, ducks, goats, and sheep. When asked how many of each she has, she said, "If I count all the legs, the total number is 244. If I count all the heads, total number is 81. None of the animals or birds are missing any legs." And this is a quantitative comparison type question, where the quantity A is the number of chickens and ducks, and quantity B is the number of goats and sheep. So we start with some notation or placeholders for the number of chickens, ducks, goats, and sheep. So number of chickens be C, number of ducks be D, goats be G, and sheep be S. So we have from the count of heads, it's just a simple summation of these quantities. Like, so C plus D plus G plus S will give us the total number of heads, which is the total number of animals. So that's animals and birds. So that's 81. Now we go back to the count of the legs, which was originally stated first. If I count all the legs, the total number is 244. So how many legs does each of these animals or birds have? So for chickens, we have 2 legs. For ducks, we have 2 legs. For a goat, we have 4. And for a sheep, we have 4. And it's stated that none of the animals or birds are missing any legs. So we don't have to worry about any missing legs. So if we want to write an expression for the number of legs, for the total count of number of legs, that will be 2 multiplied by C. So 2 legs for the chicken, or each chicken, we have C chicken, so 2 C legs, plus 2 multiplied by D, so 2 legs for each duck, and we have a total of D ducks, so it's 2D legs for the ducks. And then similarly 4G for, each goat has got 4 legs, so we have 4 multiplied by G there. And similarly we have 4S for the sheep. So we have 2C plus 2D plus 4G plus 4S as the total count of the number of legs, and that's given as 244. So if we divide both sides of this equation by 2, we end up with C plus D plus 2G plus 2S is equal to 122. And then we do a little grouping. We can take that 2 out as common, and within parentheses we have G plus S. So it's C plus D plus 2 times G plus S is equal to 122. And now we can let C plus D equal to A. So that's the number of chickens and ducks. So that's the quantity A, basically. And then we can let G plus S is equal to B. So that's the quantity B, number of goats and sheep. And we can write the first equation, which was originally in blue, in terms of A and B as A plus B is equal to 81. And the equation for the number of legs, the one in green that we arrived at, that one we can rewrite in terms of A and B as A plus 2B is equal to 122. And now this is a very simple equation system in 2 variables. We need to solve for A and B, and we can just do this by subtracting the first from the second, and we are left with 2B minus B is equal to 122 minus 81, and that gives us B equal to 41, and from it we can easily get A as 40. So the number of goats and sheep is 41, number of chickens and ducks is 40. So the quantity B is the greater, so the option B is the correct option here.